Figure 1 shows a sketch of the curve C with equation y equals f of x. The curve C passes through the origin and through the point 6, 0. The curve C has a minimum at the point 3, minus 1. On separate diagrams, sketch the curve with equation y equals f of 2x minus f of x and f of x plus p, where p is a constant and 0 is less than p is less than 3. On each diagram, show the coordinates of any points where the curve intersects the x-axis and of any minimum or maximum points. So I've summarized the question here. So there's the sketch, and we need to do separate pictures, don't we? So I'll paste in three axes with the original sketch on. So here they are here. So let's have a go at them. So the first one was y equals f of 2x. So let's have a go at that then. F of 2x, I'm going to do dashed lines because it's easier for me to draw. So here when x is 3, if we put 3 in here, we get f of 6, the value at 6. So this value here occurs here. So it's squashed up to there, isn't it? So it's squashed by a factor of 2, isn't it, basically? So here's the graph, and I'll try and draw it. The minimum will be here when you put here, it's halfway along. So this point, which is now the minimum for this curve, will be 3 over 2 and minus 1. And when you put 3 over 2 in here, the 2's will cancel, it'll be f of 3, which will be the value minus 1. So that's what we've got then. If we put x as 0 in, we still get f of 0. So it's squashed up around the y-axis by a factor of 2, so it's going to come down here, go through here, come back up here, and then squash up by a factor of 2, isn't it? So that's that one. And that's y equals f of 2 lots of x. The next one, minus f of x, is simply the y values will be inverted, won't they? So this value that was at 3 minus 1 will now be minus the minus 1, will be 3 and 1. The 0 values will still be 0, won't they? So it will just flip upside down. So it will come up, go through here, and it's just reflected through the x-axis, isn't it? So there's our curve, not very well drawn. Y equals minus f of x. Now the next one, fx plus p, where p belongs between 0 and 3, plus p. So if we had 1, for example, x plus 1, and we put in x is 2, the value at 2 would be 2 plus 1 would be f of 3, which would be this point here. So the value at 2 would be here. So it's shifted back p. So this point here moves back. It moves back somewhere between here and here, because the 3 and p lies between 0 and 3. So let's move it back this much then. Everything gets shifted back. So this 6 gets moved back, and this 0 gets moved back by a distance p. So this point here is 0 is minus p, isn't it? 0. This point here is the point 6 minus p, 0. And the minimum is moved back to here, and that was 3 minus p and minus 1 y value. So it's the same curve, but it's just shifted back a value of p. So I'll try and draw it as best I can with this marker here. I forgot to put in that point there. That's 0, 0, because it's the same as before. And this point here is 6, 0. And we've put in the maximum now. This point here is still 0, 0. This point here was half, wasn't it? That would be 3 and 0. So I think that's all the information we needed for those 3 sketches. Max or mins we've done, and where it intersected the x-axis as well.